Alright, this is Chris here, and thanks for joining us for the Model Accuracy tutorial. Excited to walk you through the software here, and we'll go ahead and get started. We're clicking on our Model Accuracy desktop icon. We're going to open up the software, and we downloaded this on the download page of the website. We also downloaded our test grib file packet and a test log file packet, and these are pretty important to run the test we're going to do here. So we'll make sure we're on the correct version, 1.006. If your version's out of date, the server will tell you that you can update your software, and that's the only piece of internet connection that the software actually needs, is just to see if you need an update. So we'll do a new race. We'll call this a test 1, our first test, and we'll click OK. And then we will have to tell Model Accuracy what to do. So our raw data, we need log files and grib files. That's what we're doing. We're comparing the log file of the true wind speed, true wind direction, and sea surface pressure captured at a geographic position and time compared against the grib file, what the weather thought it was going to do. So we're providing the truth, the boat instruments, compared to the forecast of the grib file, and then we'll discern which grib file is in fact the most accurate and why. So we have to tell Model Accuracy where to look for the log files. Now down here, this is C program data Expedition log 0. That's where Expedition normally stores your log files. And so that's an easy place to help find, and it'll help you find that log file easier. Same thing with the grib files. But I can tell Model Accuracy to look anywhere that there are log files, and mine are on my desktop right now. So let's browse and map that to the desktop, test log files. And then for the grib directory, we'll tell them where the gribs are, and my gribs are all stored on the desktop as well. And let's just peek in there. These are all, we're looking at COAMPS, GFS, NavGem, and we got one NDFG. And that's compared to about 3 days of log files. We always want to have a little bit extra log file. Our analysis mode is going to compare the most recent grib file. So whatever grib file has the freshest set of data for that time of evaluating to the log file, that's the version of that grib file Model Accuracy will be evaluating. So our analysis settings, remember the gribs and the logs must cover the same analysis time frame. If you want to look at 2 days of gribs and logs, you can't only have 1 day of logs. You have to have both, and that's important down here. So we're going to have to go with our test data, which was outlined on the website. So 2016 is the time frame for these gribs and logs from a race I did a long time ago. And June 3rd, 2016, starting at 20:30 Zulu. And remember, it's always Zulu time. There's no such thing as local time on a boat. Gribs are run via Zulu time. So here's 2016, June 5th for the bottom row. And it goes to 0:40. And we'll see that that's 1 day, 7 hours and 30 minutes. We'll keep our annulus granularity for 1 minute, and our mast height is going to be 33 meters. So the granularity, if you're doing a longer race and you want to do a fast computation, just move up your granularity, and it won't take so many data points, and you'll get your answer faster. But since our race is kind of small here, we'll just keep it at 1 minute. If you are doing a race, if you were actively doing a race, what you would do is you could put your start time of the race, and then you just keep clicking now, and that would automatically update to your current place and time. So let's prepare our data. We got logs and gribs coming, and we want to plot our true wind speed, true wind direction, and our barometric pressure. Let's click Analyze and see what happens.